Okay, suppose z is root 2 cis theta, where theta is obtuse. Find the modulus and argument of 2z and 1 minus I times z. Okay? Well, we're probably going to need to use this part later on, but for now, let's just leave that alone and just figure out what 2z is, okay? So if I do 2z, I'm going to have 2 times the quantity root 2 cis theta, right? Okay, and then this becomes 2 root 2 cis theta. Okay, so here's my modulus and here's my argument. So it's pretty simple. The modulus then of 2z is going to be 2 root 2. That's a 2, sorry, not a z. Okay, and the argument of 2z is then just theta. Okay, pretty straightforward. Okay, what about b? What about if I have I, or 1 minus I times z? Okay, well, 1 minus I, let's write this part in polar form, and then I can multiply it with z in polar form. So 1 minus I would look like 1 minus 1. Okay, so that would be 45, 45, 90. So that would be root 2 over 2 and root 2 over, so that would be 1, 1, and root 2. So that would be root 2 cis of, what's the angle there? It's negative, so it'd be negative pi over 4. Okay, and now so that would be 1 minus I. The z part would be just root 2 cis theta. Okay, so when I multiply these two, now we just have the same thing that we had before in our previous example, 2 times cis of theta minus pi over 4. Okay, because these two we would add, right? Okay, and so now the argument, or sorry, the modulus of this whole product, so the modulus of 1 minus I times z, okay, of 1 minus I z would be 2, okay, because that's this part right here, and the argument of 1 minus I times z, okay, would be theta minus pi over 4. Okay? Okay, example 9. Suppose z is cis phi, where phi is acute. Find the modulus and argument of z plus 1. Okay, so what we're going to do here is we're going to try to find what z plus 1 is, and this time we'll be using vectors. Okay, so if we draw our circle here, we know that z has a magnitude of 1, okay? So, and it's acute, so it's got to be in this first quadrant here. So z is going to be somewhere over here, okay, anywhere here. And since we're looking for z plus 1, 1 would be over here. This would be 1, right? So I need to find the addition of those two vectors. So that would be 1, and so this is the vector that I'm actually looking for. So if I can find the modulus of z plus 1, if I can find what the modulus of z plus 1 is, and the argument of z plus 1, okay, then I have solved my answer. Okay, I've solved this question, right? Okay, so let's use geometry here. How am I going to find this modulus? Okay, how am I going to find the modulus and the argument of this vector? Well, I know that this has a length of 1, don't I? Because this is on the circle. Okay, so this will actually be 1, and that will be 1, that will be 1, that will be 1, right? So it's actually going to be a, since these are parallel, okay, and these are parallel, this is going to be a parallelogram, but a special kind of parallelogram. It is actually a rhombus, okay? So a rhombus has diagonals that bisect each other and are perpendicular. So these are the same, these are the same, and also the angles on a rhombus are bisected by the diagonals. Okay, so this angle would be the same as this angle. Now I do know that this angle here is phi, so that would mean if this is bisected by the diagonal, this must be exactly the same as this, which is going to result in this being phi over 2. Okay, so this angle here is phi over 2. This is 1. I now need to find, so basically I've solved this part. The argument of z plus 1 is phi over 2. Okay, phi over 2. What I'm left with now is finding this part, the modulus. Okay, so I need to find this length and this length combined, right? I need to find this total length, but I notice that this is a right triangle, so if I can find this length, then I can just double that and I'll get the modulus of z plus 1, because this is half of z plus 1. Okay, so this actually, if I were to find this is the adjacent side, so cosine of phi over 2 would be whatever this is, let's just call that x over 1, right? And so the cosine of theta phi over 2 is just x. So if I double that, that is the modulus of z plus 1. So therefore z plus 1 is equal to 2 times the cosine of phi over 2. Okay, so that's one answer there. That's one part of my answer there, and this is the other part of my answer there. Okay. The remainder of this section is on finding Cartesian form from polar form or polar form from Cartesian form. Okay, it's basically the same thing. It's just that if I'm given something in component form, remember that the components, the magnitude, the r, okay, the r is still can still be found using Pythagoras' theorem. Okay, using the components, and this formula here, cosine, is just this is just x over r cos theta. Y over r is the sine of theta, so r sine theta is y, and the tangent, of course, is opposite over adjacent. Okay, where that's theta. All right, so you can use these ideas to convert between polar and Cartesian form, and on your calculator. The way you're going to do this on your TI Inspire is, if you can take out your calculator, when you punch in component form into your calculator, sorry, cis, if I had some like cis of 30 on your calculator, you would actually put, okay, so on your calculator you'd need to type this in as cosine of 30 plus I times sine of 30, or these could be switched around, assuming we're in degree mode here. Okay, and what you'll do here is put this into, if you wanted to, let's say this, since I have this in cis form, if I wanted to get it in component form, okay, since this is basically polar form, this would be polar form. Okay, to get it into rectangular form, what you would do is you need to go to, once you've input this, click on menu, okay, number, and then complex number tools. Okay, that's number 9, complex number tools. And once you hit that, you have now two forms here, two numbers. So if I have to get into rectangular from polar, okay, I would use number 6, convert to polar. Okay, and if I wanted to get from rectangular to, polar to rectangular, okay, I would use number 7, which is convert to rectangular. Okay, so play around with this, and if you have any questions, come to class with your questions, and I'll be happy to answer those questions for you. Okay, all right, thank you guys, and good luck with your homework.